Illarionov, who I've known for about 5 or 6 years. We've worked together on a variety of projects, most of them relating to climate change. But Andrey is most famously was chief economic advisor to President Putin. In fact, there's in the most recent edition of The Economist, he's cited as being the progenitor of the economic reforms that Putin underwent that actually led to some improvements in that country. That was before the reforms that have led to certain questions about whether there's going to be improvements in that country. Anyway, we shall say no more about Russia right now, and rather hand over to Dr. Illarionov, who will present for about 15 minutes, we hope.
Good morning, ladies and gentlemen. It's a great pleasure to be here and to meet and to see very many good friends for many years. And it is also very pleasant because a lot of good ideas have already been put forward, and that is why probably it's not necessary to repeat some of them and also some arguments. But nevertheless, some of them, I will mention again. So my topic today is the topic that actually is provoked by the many statements by ICCC and by the people who are arguing for limitations of CO2 emissions and even for reduction of CO2 emissions. What will happen, or what would happen with one particular issue, economic growth, if, let's say, the decision to reduce CO2 emissions will be mandatory for not only a particular group of countries, but for the whole world. Let's look what could happen. First of all, look for some observations. First of all, patterns in human-induced carbon dioxide emissions, and we'll start with this picture. As you can see here, the lion's share of the world energy consumption is hydrocarbons, and it is interesting that this famous 87% that Michael Economides has cited just a few minutes ago was, according to this data from International Energy Agency, was almost correct for 71. For year 2000, it's slightly less, it's about 80%, and the difference probably is due to this data came from IEA, not from the respected company Exxon that Michael has cited. So this is very interesting because, in essence, it actually confirmed the point that he has made. The patterns for consumption of energy is very inert, so it does not change overnight. It's actually, for any serious structural change, it takes years and decades and maybe centuries. Based on this data, we can say that the possible reduction in share of hydrocarbons in total energy consumption goes on with a rate probably 2.3 percentage points within a decade. So that is why, even assuming that there are some changes, it really takes decades or maybe centuries to substantially change the structure of consumption that we have today, and it means that hydrocarbons will be the main source of energy consumption in any foreseeable future, certainly for the coming century. Though this fact is confirmed not only for the whole world, but also for most of the countries. Here, you can see this correlation between hydrocarbons consumption and GDP as overall, which shows a pretty high level of correlation. Another very important correlation is correlation between hydrocarbon consumption and CO2 emissions. For example, last 30 years, hydrocarbons consumption increased by 39.7%, according again to such a respectable source of information like IEA. And it is interesting that CO2 emissions increased 67.7%. It means that over 3 decades, which is quite a substantial portion of time, there was almost no any tangible improvement in so-called some kind of decline in the intensity of CO2 emissions per unit of used hydrocarbon. So that is why technologically looks like it is next to impossible to substantially reduce intensity of the emission per unit of consumed one particular unit of hydrocarbons. So that is why carbon dioxide emissions are the natural result of energy consumption and are an inalienable product of economic growth. And this is very well known. So here we're looking for the raw data for last almost 150 years of carbon dioxide emissions. This picture is actually like a picture for GDP or GDP per capita, or for most of the indicators demonstrating the progress of human civilization. This carbon dioxide emission is a lineable feature of modern civilization. And there are just really few time periods where we can see some kind of reduction in absolute terms of carbon dioxide emissions. They are really some kind of a cataclysm in the world human history, both world wars, the largest economic crisis, and the crisis in transition economies. And with the exception of those periods, carbon dioxide emissions grows. And this growth is forecasted to continue further, based again on the data from the International Energy Agency, at least based on their assumptions, including assumptions for some kind of progress in technology dealing with carbon dioxide emissions. Now, just have a very short word into the theory. Theory, we have a very important element that I would say called the theoretical Kuznets curve in application to this carbon dioxide emission. We certainly can predict that some particular non-linearity of relation between level of economic development and carbon emission exists. And carbon emission could be total, per capita, per unit of GDP, and so on. And any limit that is shown here in the red line would certainly limit those countries and companies or societies to move further on, not only upward, but also just from left to right, so to higher level of GDP per capita. It is interesting that it will put the real data for, we have something about 130 or 140 countries, so we actually have a very clear picture which is very, very similar to Kuznets curve. Here, Kuznets curve for carbon intensity of GDP, it's 120 countries here. So it looks like it's really this Kuznets type curve that exists for carbon intensity. It was some kind of distinction. We would take all these 120 countries for three groups of countries: low income, middle income, and high income. Once again, we receive confirmation not only from one particular period of time, but for the last 50 years. So low-income countries on the left side, so increasing their carbon dioxide intensity per unit of GDP produced permanently. The same for middle-income countries in the center, and only high-income countries, and only from 1970s started to decrease slightly carbon intensity of their GDP. So once again, this is a Kuznets curve. That is why restrictions of any kind in carbon dioxide emissions put at any level are particularly discriminatory against low and middle income economies that did not reach some particular turning point, some kind of the highest level. So that is why for them it will be, in this case, in the case of the establishing such limits, it will be virtually impossible to break them and to stay in the low level of economic development. Here another just some kind of particular picture demonstrating elasticity coefficient for CO2 emissions versus economic growth for countries with GDP per capita less than $15,000 in 1999 prices, exactly the same. Another demonstration of the three group of countries: fast-growing countries, slow-growing countries, and countries with GDP per capita growth close to average among 150 countries over the last 55 years, showing that the fast-growing countries did have higher emission of carbon dioxide per unit of GDP, so highest, not only emission, but highest growth in this intensity. And those countries that were having much lower carbon intensity, and that carbon intensity growing slower, also growing much slower. So this is observation, this is a theory. Let's look for experience, the practical experience. Whether we can find any examples that some particular countries, some particular societies over the last some particular years were able to reduce carbon dioxide emissions. And we arrived to this picture in which we have data for 198 countries, almost for all countries in the world, for the last decade. And we can see here that for 151 countries, it's a very clear sign that CO2 emissions increased over the last decade. But that's a great victory and support for our colleagues from ICCC and others. 47 countries really reduced carbon dioxide emissions. And they could be very proud and oh, it's okay. It's what we're talking about. It's not something really some kind of illogical as some strange people claim here. But it's a confirmation. 47 countries is one kind of total list. Let's look at them. This isn't just, they have entered the so-called green trend. Right. Okay. Let's look at these countries. What are those countries? Okay, in 31 countries, reductions in carbon dioxide emissions was accompanied by reduction in GDP per capita. And you can have them, these wonderful countries, number of countries from transition, some kind of from Central Europe, Eastern Europe, former Soviet Union. Here they have wonderful country, some kind of Azerbaijan, Zaire, Georgia, Moldova, and others. Okay, but there are 16 countries out of 198 in which reduction in carbon dioxide emissions was accompanied by increase in GDP per capita. So it's exactly what our so-called colleagues are talking about. Let's look at these countries. As you can see, these trends go in opposite directions. What are those countries? Out of these, some kind of 31 countries, you can see this 13 countries in transition to centrally planned economies, like Cuba and North Korea, and 6 countries affected by conflicts: Afghanistan, Congo, Liberia, Zaire, Zambia, Zimbabwe, and by some chance, Bermudas also happen to be in this group. What is much more interesting, who happen to be in the group of countries of these 16, where is rising GDP per capita and decline and reduction in carbon dioxide emissions? There are 3 subgroups. 8 high-income countries that are actually located on the right descending part of the Kuznets curve, like Luxembourg, Denmark, Finland, UK, Germany, the Bahamas, Puerto Rico, and Malta. So for them it's okay. That's exactly what is predicted by the theory. 2 countries in transition, Poland and Hungary, both relatively developed countries with very high level of carbon intensity inherited from the central planned economy past, and 6 low-income economies, so they should be on the left, some kind of ascending part of the Kuznets curve, like Sudan, Chad, Swaziland, Fiji, French Polynesia, Papua New Guinea. Here, they are true champions of the green trend. These 6 countries again: Sudan, Chad, Swaziland, Fiji, French Polynesia, and Papua New Guinea. So that's an example that all the rest of the world should follow, because it's a really green trend. It's not a worldwide pretend. So the problem is, the first problem, that the contribution of these 6 countries into the world CO2 emissions is 4 hundredths of 1%. And 23 hundredths of 1% in terms of GDP. And to be correct, it's necessary to say that Sudan, Chad, and Papua New Guinea is in a very special, understandable why they are here. Because in all 3 countries, quite a big developments of oil fields started in the last decade. And since those countries do not have any processing industries to do anything with oil, they're just shipping this oil outside. But certainly GDP is calculated, substantial rising GDP due to this exploration, but there is no CO2 emissions because there is no processing of that. So that is why true champions in green trends are 3 countries: Fiji, French Polynesia, and Papua New Guinea. And frankly speaking, I was not able to calculate their share in CO2 emissions and world GDP so far. But nevertheless, that's an example that our colleagues want the rest of the world to follow. How much time do you have? 2 minutes. Okay. Just I would spend these 2 minutes to some kind of discuss one particular special issue that actually attracts a lot of attention by colleagues. They are talking. Okay. What is important to jump to another level of economic development, to another technological level, and for that purpose, it is necessary to reduce carbon intensity. It is correct that if you'd like to reduce emissions, you can affect either population or GDP per capita or carbon intensity. There is no other way. It's pure mathematics. So that is why it's very important to find a way how to reduce carbon intensity and how much can reduce carbon intensity. Here is a picture for carbon intensity per unit of GDP, depending on GDP per capita, based on the 170 years for 5 countries: USA, UK, Canada, Germany, and Belgium. It's very clear that until those countries, on average, reached the level GDP per capita, 18,000 US dollars by PPP in 1999 prices, this carbon intensity was increasing. And only having reached that level, they were able to stabilize the carbon intensity for those countries. So it gives us to think about what actually behind this level. I switch some of the slides. Another very important factor that influences this carbon intensity, the air temperature. And look at this and kind of the angle of this trend, because on X is the air temperature, on the Y is the carbon intensity of GDP. So it looks like the carbon intensity is higher when the world is not warm, when it is cold. What a surprise. So that is why when it's usually cold, some people, it's not clear why they're increasing some kind of carbon intensity of their economies. And here is just another example, taken from the UK, because a lot of Brits, as Julian has said, especially for you, our friends and colleagues. Here is carbon intensity in GDP and changes in air temperature in the UK. UK is a wonderful country, and the UK government is very much interested in reduction in carbon intensity of GDP and some kind of putting emissions targets. So look at this, how these changes in air temperature, the inverted scale, affected carbon intensity. When temperature, by some not quite understand reason, was falling on our British islands, the carbon intensity of GDP in Britain jumped. As you can see, this is a spike. But when it became warmer, it's once again as inexplicable, just it's fall down. And just it's all over these last 25 years. So once again, it is strange, but probably some members of the UK government also doing, increasing carbon intensity of their GDP, or their some kind of private GDP, some kind of warming their houses when temperature is really low, not when it is high. So very last, a lot of formulas here, but some of our colleagues have mentioned them. Here are the 3 most important factors for actually four elements, so that is why we can define any of these 4 elements, either economic growth or emissions of population and carbon intensity, playing with 3 others. So that is why we would like to understand what would be the economic growth rates here in terms of growth rates, given that emissions, let's say, would not increase. I'm not talking about the reduction in emission, just stabilize emission at the current level. With population level, population growth increase is 1%, and carbon intensity reduction 2% per year, which is incredibly high, which is actually has been observed only in very particular cases. It's not some kind of regular case. In all those conditions, we would arrive to the conclusions that if these mandatory limitations for carbon dioxide emissions will be established, the GDP per capita growth rate could not and must not exceed 1% per year. If by any chance the emission target will be established at such level that it would be necessary to reduce it, as it is, as we know, according to Kyoto, all different proportions, it means that GDP per capita growth rate would be lower than 1%. And if those rates, this target is 50% within 42 years period of time, it means that the GDP per capita growth rate in this particular case should be